Hey guys, Christian here. So we've moved into the world of logarithms, specifically solving logarithmic equations. Now, a lot of the time these can be a real pain for a lot of students because they just don't know where to start. And the key here is to make sure that you are an absolute master of the index and log laws, because without those, you actually have no chance of getting through any of this. So typically speaking, when you've got a question like this, we've got a couple of logs on each side and they're all the same base. You can usually combine them in such a way that you'll be able to cancel the log, but at present you cannot just make all of the logs disappear. The only time you can do that is if you have a single log function on either side of the equal sign with no external terms. So what we're going to do is we're going to use the log laws to try and combine the left-hand side into one neat log form and the right-hand side into one neat log form, and then maybe we'll be able to cancel out the logs. So using the log laws, they're really simple. The first log law basically says that if you've got two logarithms of the same base that have been added together, you can combine the logs by multiplying the arguments, which is the piece on the inside of, say, the brackets. So in the case of the left-hand side, we've got log e x and plus log e 2x minus 1, which means we can actually combine them to make log e of x times 2x minus 1. So you actually multiply the two pieces together. On the right-hand side, we can do a very similar thing by multiplying the 3 and the 1 minus 2x. I've just put the 3 out the front for convenience sake. Basically, we can now get rid of the logs, and while we're at it, we'll also simplify those pieces on the inside. So now that you've got a single log on either side, technically what we do here is we apply the exponential function to both sides, which would cancel out the e. So what you technically are doing is you're going, okay, e of that and e of that, and then the log and the e will cancel each other out, leaving just the left-hand side of x times 2x minus 1, which we should simplify. And on the right-hand side, we'll have 3 minus 6x. Now we've got a relatively simple problem to solve, but there is one last trick at the end, and I'll show you that in a second. What you've got here now is a quadratic function. It's not the prettiest, but it is a quadratic function. The highest power of x is a squared term, so we can actually use our information about quadratics in order to solve this. So when we're working through a quadratic, the way to solve it is to get everything over to the one side, let it equal 0, and then either factorize it or use the quadratic formula, whichever one's more comfortable. So we've already got 2x squared on the left. We'll bring the 6x across, which would make plus 5x. And then once we've got that, we can move the 3 across, which would give us minus 3. And then we'll have that equal 0. Now, if you are happy to factorize that, just using either the cross method or whatever other method you've learnt, that's great. You would end up getting to the point where you've got 2x minus 1 and x plus 3. And that's really simply just using like the cross method. You'll be able to work through that. If you're not comfortable with the cross method, you can use the quadratic formula to solve this. It's a very simple quadratic and it'll get you through to the end. So whichever method you're more comfortable with, that's the best one to go with for this quadratic. Once you get to this point, if you've chosen to factorize, all you have to do is finish it off. So we'll have 2x equals 1, therefore x equals 1/2, or x equals negative 3. And it would look like that's the solution, but with logarithms, there's one final trick that we actually have to think about. So we've got two solutions, which for a quadratic, completely normal. The problem here is, by definition, a log cannot have a negative argument. It can never have anything that's a negative on its inside. So here, for example, x physically can't equal negative 3 because we can't take the log of negative 3, which means that while this solution did match the quadratic, it does not match the original question, which means we have to exclude it because we only really care about the original answer. This, on the other hand, gives us x equals 1/2. Now, when you've got x equals 1/2, this would be log of 0, and we can't do that either, which means we have to kick out this term. So despite the fact that we've done a whole lot of work, it turns out that this question actually has no solutions. Weird, right? Like, it's a bit different, but these questions can pop up. So despite the fact that you've done all the work and you found two valid solutions for a quadratic, the original problem does not have any solutions whatsoever. Now, this is the part that gets most people, because if this was in an assessment, all of the work would be expected so that you can show that the equation actually has no solutions and why it has no solutions. So be really careful at the end of any log question. go back with your answers and see, does it fit in the domain of the original question? Guys, that's it for me today. As usual, if you found this video useful, please like it, share it with all your friends, head over to the page and like that. I would really appreciate it. You know, I do this so that you guys can get as much help as you possibly can. That's it for today. I'll see you guys on the next one.